All right, we got lesson 2.1.3. Today we're going to dive in a little bit deeper into slope. The questions we want to start asking ourselves and answering through this lesson are, how can we tell if a slope is going to be positive, and how can we tell if the slope is negative? You know, what makes a line steeper than another line, or what makes a line that's less steep? Or what does a slope with zero slope look like? So we're going to be looking at that and answering those questions today. First thing I want to talk about is how slopes, the slope triangles that we make are kind of like stair steps. You know, in my house, you know, the stairs are kind of like this, so not too bad to go up those. But imagine, look at the slope triangles in this one. Look how high they are. Those would be the type of stairs that would like kill your legs as you keep on going up it. Or you got these ones, like this one and this one. I don't know if you've ever been hiking in the mountains, but you'll come across a lot of different stair steps. You know, if you're going up in Yosemite, around vernal falls or vernal pools or something like that, some of the steps are super, have a lot less steepness, where you kind of walk a little bit of the ways, then you step, then you walk a little bit of the ways, then you step. Whereas other ones, you know, you have to take really big steps, you know, going up it. So these slope triangles that we're making here, they're a lot like just steps to get from one point to the next point. And we notice here that no matter what, since they're lines, all of these slope triangles are equal to each other. They're all the same in the same line. You know, different lines have different slope triangles, but on the same line, they have the same slope triangle. All right, so looking at this one, which one looks like it's the steepest line of A, B, C, and D? I think it's pretty obvious, maybe, that B has the steepest steps that we would have to climb. So I would not want to have to go through like 20 of these. That would kill your legs if you did that. So we're going to say that B is the steepest of all of those. All right, so we've got A, B, C, and D. D is a little bit different. How's this one different? It looks like A, B, and C, we're all going uphill on those. So from left to right, we're going uphill. Whereas on D, we have a downward slope on this one. So D has a downward slope. All right, so next we're going to find the slopes of those three lines. So looking at A, it looks like the change in the x value is 1, and the change in the y value is also 1. So remember, for A, we would say the change in y over the change in x. And that would be 1 over 1, which is just 1. For B, B looks like it's going, the change in the x is 1, and the change in the y looks like it's going to be 1, 2, 3. So for B, we've got the change in y over the change in x, and it looks like 3 over 1, which reduces to 3. For C, it looks like the change in the x right here is it's changing by 2, and the change in the y is it's changing by 1. So for C, the change in y over the change in x is 1 over, what did I say, 2? 2. So we got 1/2. That one doesn't reduce. Finally, we've got D. D, from side to side, looks like we're going 1, 2, 3, 4, 5. Is that 5? 1, 2, 3, 4, 5. Yes. So the change in the x value is 5, whereas the change in the y value, it's going down 1, 2. So when we go down, that's a negative. So our change in y is a -2. And our change in the x value is a +5, so -2/5. Remember, you can have the negative on top, or you can have the negative out front. Doesn't matter which way. Okay, so we got uh, 4 different slopes there. We want to see how the slopes relate to the steepness. Well, we already said that B was the steepest one, and B has the greatest slope. The next steepest line was A, and it has the next steepest slope. The least steep of the lines that were increasing was C, and it has a slope of 1/2. So we can see that the steeper the line, the greater the slope. And then we also saw when we had a line that went downward from left to right, gave us a negative slope. So positive slopes, they go from left to right, upwards. Negative slopes from left to right go downwards. All right, so on the next problem, I've got all these beautiful lines right here. I want you to find the slopes of each one of them. All right, I'm going to pause it. So this is where you do some work on your own, and then we'll check your work. All right, so we're going to pause. So pause your screen, please. And I'll be right back. All right, we are back. So I saw with line A, I made my slope triangle. It looks like my change in the y was +2, and my change in the x was +1. So that is a slope of 2/1, which reduces to 2. And then I went over to B in green. I made my slope triangle right in here. So it looks like it's going, our change in our y value is 3 right there, and then our change in our x value is 2. So that would be 3/2, which is 3/2 or just 1.5. C, I did in orange. It looks like this one is going up 2, but then the change in the x is 3. So that's 2/3, which you could say 0.6 repeating if we wanted to, or just 2/3. And then on D, this is the only one that was going downward from left to right. So up and down, I've got a -1. Sorry, it looks like positive because I scratched out. And then on our x, our change in our x is 5. So this would be -1 because it's going downhill over 5. And I guess we could have also said that this was, or -0. What's that, 2? All right. And then lastly, in this bright green right here, we had E that is just a flat line. So that means it's not going up and down. So there is no change in the y values. But the change in the x values between these 2 points right here would be 5. So I got no change in y for a change in x of 5. 0 divided by 5 is 0. So here we need to look at a couple things. First of all, there were 3 of them that had positive slopes, and all 3 of those were going upwards from left to right. We had one of them, D, that was going downwards, and that one had a negative slope of -0.2 or -1/5. And then finally we had E, which was a horizontal line, which does not go up or down, it just stays flat. Now, since slope is talking about how steep the line is, it makes sense that its slope value would be 0, because this has no steepness at all. It's flat. There's no stair steps going here. So no steepness, 0 steepness. So slope is still defining how steep the line is. So positive slopes, a negative slope, a 0 slope. Also, we saw that our steepest line was A, and look at the number, 2, 1.5, 0.6 repeating. 2 was the steepest one. This is the next steepest line. And then this is the least steepness of those ones. And then you have this one that was going downhill, so it had a negative slope. So slope describes how steep the line is going to be. All right, let's move on to our last page here. All right, last one, or last page, we're almost there. So I've got several lines here. I want you just to find out which ones have a positive slope, which one have a negative slope, and which ones have a 0 slope. So do that on your own. I'm going to pause in 3, 2, 1. Pause yours, please. All right, you should have seen that the negative slopes were A and B, the positive slope was C, and the zero slope was D. So we already know that if this is a zero slope, its slope will be 0. Let's look at A real quick. Okay, so A, I'm just going to choose this point and go over to here to make my slope triangle. So it looks like it's going down. These are by 3s. So it's going down 3, and then these are by 1s, I believe. No, these are by 1s. Sorry. This is the axis. So this is 5, 4, 3. Yeah, okay. So it's going down 1. Wow, that was bad. And it's going over 2. So we would say that A would have a -1/2 slope, so -1/2. B, let's pick 2 points on B. Let's go way down over here. So here's a point on B, and here's a point on B, so let's make the slope triangle right here. And it looks like that one's going down 2 and over 1. So down 2 and over 1 would be -2/1. So they're both going downhill, but we can see that in terms of absolute value, this is the biggest number. So that's why B is steeper than A, because if you ignore the negatives, 2 is a bigger number than 1/2, so B is the steeper of the two, even though it's steep going in a negative direction. For C, let's just pick this point here and this point way over here. It looks like our change in y is +2 and our change in x is +3. So we have a slope of 2/3. So there's our different slopes. All right, next. All right, I want to make a line that goes up 3 times each time it goes over 5. Okay, it has to go up 3 and over 5. So it doesn't say where it has to start or where it has to end. So I'm just going to say, okay, so it has to go over 5, and that's a positive. So I'm going to start here. It's going to go over 1, 2, 3, 4, 5, and up 1, 2, 3. So there's a slope triangle of to the right 5, going over 5 and up 3. So this would be line A. This could be line A. You could have drawn it somewhere else if you wanted to. So there we can see that we've got a slope triangle that the change in the x is 5 and the change in the y is 3. All right, next one. A line with a change in x of 4 and a change in y of -6. All right, so let's say that I started, where do I want to start for this one? Let's start right here. So the change in x is going to be 4, so I'm going to go 1, 2, 3, 4, and then the change in y is -6, so it's 1, 2, 3, 4, 5, 6. That would be right here. So that would be B. Could it have been another line? Yes, we could have started anywhere we wanted to make this. But here we can see that our triangles, you can do the triangles below it or you can do the triangles above it. Doesn't really matter. It's still a stair. But notice this one, the change in y was negative, so we have a negative slope on this one. So this was +4, and this is -6. So this one's going downhill. Next one, we want to change in y to be the same as the change in x. Okay, that's a little bit more difficult, but I think this is doable. So let's just start right about here. And let's say that I want the change in x to be 2. So if the change in x is 2, this one says the change in y has to be the same thing. So I'm going to go 2, 2, and this would be our line for that one. because in this instance, my change in x was plus 2, and that made my change in y plus 2. All right, let's do our last one. Our last one says a line that has a change in y of 3 and a change of x of 0. So side to side, it's not changing at all. So I'm going to start here. And then I'm not going to be able to go side to side. It just says the change in y is 3. So I'm just going to go up 1, 2, 3. And now I have this line. Because I can see between these two here, I've got a change in y of 3, but from side to side, it's not changing at all. So we can't even make a triangle off that one. So that's a little bit of a problem that we'll talk about in a second. All right, let's move on to our last couple questions. Which line from the previous problem was not our function? Well, probably the one that gave us a bit of a problem and didn't make a slope triangle. This one right here. This one was not a function. So part D did not give us a function. The reason why it's not a function, because look at these 2 points. This point is at 1, negative 4. This point is at 1, negative 1. We've got the same x value with different outputs, which means it'd be like a calculator that you plug something in and then get 2 different answers for it, which doesn't make any sense, right? You want one answer when you plug something into a calculator. So this is a non-function. So the D is a non-function because I'm running out of ink. It's going to make me sad. I like my orange. It is running out of ink. So sad, orange. Thought you still had ink. I think it does, but we'll worry about that later. Because for the x value of 1, there's more than one y value. For the input, let's write that. Input of 1, there is more than one output. So that is not a function. All right, the last thing says, draw a line with a change in x of 0. So if we're looking at our change in y over our change in x, they want the x to be 0, so we can make the change in y to be anything we want, like 2. That would be like the orange one we just did, D, where it would be a vertical line, where it starts here and then we go up 2, but the x isn't changing. Okay, then draw a line with a change in y of 0. So we've got change in y over the change in x. So for this one, we would say the change in y has to be 0, and let's just make the change in x 3, just because I wanted to. And that one would be a horizontal line, because the x value is changing by 3, but it's not going up and down. So we see here that we have horizontal, and this has a 0 slope. So horizontal lines have a 0 slope, because 0 divided by 3 is 0. Now let's look at this one. This one was a vertical line. First thing we know about vertical lines is they are not functions, because you have more than one output for any input. The second thing that I know is I cannot have 2 divided by 0. We covered that in the last unit. That makes no sense. It's like giving me 2 pieces of no pizza. That's crazy talk. So what we say for this one is that there is no slope. Not 0 slope. 0 slope was when it was horizontal. We say it's no slope because there's no way to actually give a number to perfectly up and down. Because remember, slope is how steep it is. Well, if you're so steep that you're the steepest of all steepedness, there's really no way to describe that. So we just say no slope at all. It's perfectly steep. It's up and down. Vertical, no slope. Horizontal, zero slope. All right, so we're to our learning log. This is where you need to write me a few sentences, okay? I want you to consider the lines that we looked at today. All the different lines that we're doing the slopes on. How can you tell if the slope is positive, negative, zero slope, or no slope? So we're just talking about that. Write it down so that it gets in your head. When comparing two lines, how can you tell which one is the steepest of them all? All right, so that's what you're going to answer in a little bit. Before we do that, we have a little bit of the methods and meanings. And this is over the best line of fit. So we're going to especially see a little bit later when we do a unit that covers some data, is that sometimes our points don't match up and they're a little bit random. These points are a little bit random, but they kind of go in the same general direction. So a best line of fit is like a straight line that we can draw right through the middle of the data. So this is like a scatter plot where all the points are all scattered around. And sometimes what we can do is we can draw a line through those points to kind of represent about where the points is. It's not going to be perfect, but it is a generalization of where those points are going. Okay, so it says the best line of fit is a model, which means it's not perfect, of a numerical two-variable data. Okay, so it helps us describe the data and make predictions. And anytime you're making predictions, you're not going to be 100% accurate. So, this just gives you a general idea where things are going and helps you predict in the future. So that's a best line of fit. It's putting a line through the data to describe the relationship between those points. And generally, you want all the points as close to the line as possible. All right, we are done. Make sure to write that learning log for me, please. So full sentences, do not skimp and just write one word or two. I do not like that. Write like I know you can. All right, good luck. I'll see you next time.